to this talk on streamlining large-scale Java development. So, as Adele already mentioned, this is actually a 15-minute talk that we're going to compress down into 40 minutes, so wish me luck. With that being said, before we get started, I want to let you in on a little dirty secret of conference speakers. Because often when people talk at conferences, we would like to talk about new technologies that are exciting and big, right? So go to Kotlin, choose a new language, do microservices, change your architecture. And these are all pretty interesting and good talks, and I'm guilty of those as well. So yeah, count me guilty as charged. But what can you take away from that tomorrow to your teams, right? What can you actually apply from what you learned? And often it's not that much, or maybe it's a long-term thing, and that's good. What I want to do today is I want to talk about a tool which is much, I would say much easier to bring to your teams. This is something that you can apply to any Java code base. And we actually heavily use this at Picnic. So I'm going to share what that tool is and how it works, and hopefully you can take this away. So in fact, I'm going to teach you a superpower. Can Java developers have superpowers? Well, yeah, you can. And the superpower that I'm going to talk about today is the ability to be able to refactor your Java code bases at scale and to enforce uniformity and to help your development teams focus on the real issues rather than on the side issues. And with refactoring at scale, I don't mean people frantically typing behind their IDEs and knowing all the shortcuts in IntelliJ. That's also nice. No, I'm talking about something that we can automate using code, of course, because we're developers and we want to use code to actually make code better in this case. And the tool that we use at Picnic for that is called Error-Prone, which is an open-sourced tool by Google. It has been open-sourced a couple of years ago. We use it quite heavily. It is not that well known yet in the Java community, which I think is a pity. Also one of the reasons why I'm doing this talk and sharing this with you, because I think there's a lot of power in there that we have not tapped yet as a Java community. So yeah, Error-Prone is definitely your gateway into this new superpower, I would say. So why do we do this? At Picnic, we are tackling what we call the online groceries challenge. So we want to make online grocery shopping fun, easy, and affordable for everyone. And indeed, that means these cute electric vehicles driving around, but it also means that we need a lot of software to make this happen. There's the obvious app and the backend that goes with that, but there's so much more happening in the background. We need to do purchase order management. We need to do warehouse management. We even built a fully automated warehouse, and we need to control that as well. And for all of these systems and for all of these products that we're building, we're mostly using Java at Picnic. So that means that by now, we've actually amassed quite a few lines of code, I would say. So we started 7 years ago with a handful of engineers, currently over 200 people, are currently part of the tech team. And we've written a lot of Java code, as I said. And that means that we also have a lot of code to maintain, and not just to create new services, but to also improve and to keep evolving. And for that to work, and for that to happen, we turn to automation. And Error-Prone is one of the tools in the arsenal, let's say, to make this reality, to actually be able to scale our engineering efforts and to be able to have nice Java code bases to work with and to have some uniformity in there. So that is a bit of the background on how we ended up where we currently are. Now you might be wondering, okay, I also care about my software quality and about my code base. So, for example, I use SonarQube. And that is great, don't get me wrong, right? So Sonar and all these kind of analyses, they do help you understand your code base, they do help you see trends in code bases, etc. But there's also a bit of the sort of broken window theory going on here, because how often does a developer open Sonar? Is it actually embedded in your development cycle? Isn't it a bit too far away? And if you open your console and you see you have 80 days of technical debt and it grows to 85, I mean, what does it actually mean in terms of actionable things that you can do? So while it's good to get insights, it is not always the silver bullet to improve your development processes and to actually get better and to actually structure and get to a uniform code base. But there's more tools, right? So in the Java world, we don't just have SonarQube to actually understand and know our code. We also have some tools that help us prevent getting things from worse, right? Like spot bugs that we can use, or check style. And these are very fine tools in their own right as well. But the point is, these tools, they yell at you when you're doing it wrong, which is okay, I guess. But they don't really help you improve your own way of working and actually encoding your own patterns and your own idioms in these kind of automatic checks. So yes, they're helpful, and we use them for what they're worth. But we want to go a step further, right? So we also want to be able to actually implement our own patterns and our own refactorings, our own improvements in code bases. And that is where error-prone, together with Refaster, another Google project that's closely related, comes in. And these together actually help us to automate improvements and to take a proactive sort of stance here rather than a reactive stance in the way we structure our code bases. So what is error-prone? Well, error-prone, as I said, is an open source project by Google, and it's actually a Java compiler plugin. Can a Java compiler have plugins? Well, yes, it can, and also not that well known of a functionality. But for these use cases, for a static analysis tool, and also, as we will see, a rewrite tool, a compiler plugin is a pretty good match. So error-prone is a compiler plugin that you can just configure in the compiler invocation, which also means that it's relatively independent of your build tool. So you don't need a specific plugin in Maven or Gradle or whatever. You just need to configure error-prone as a compiler plugin, and you will be done. And there's a host of checks that you already get out of the box when you do so. So when you apply error-prone and when you add it as a compiler plugin, you will already get a lot of automated sanity checks during your Java compilation. The nice thing is that it supports a wide range of Java versions, including modern versions like Java 17, which we're pretty happy about because we migrated to Java 17 roughly 3 or 4 months after it was released. So for us, it is important that these tools are also available in supporting modern Java versions. And like I said, out of the box, you get a lot of bug patterns and bug checks that error-prone already spots for you. And it is actually interesting if you go to the error-prone website, you will see this testimonial by Doug Lee, the guy who created the Java util concurrent libraries. And he says, well, it's definitely embarrassing. I guess I'm back to liking error-prone, even though it sometimes annoys me. I think we can recognize the sentiment, right? If the tool always knows better. But it actually discovered a bug in the concurrent hash map implementation. So that's a pretty good testimonial, I would say. But then again, we can talk a lot about the tool, but let's just dive in and have a look at some code, right? And let's have a look at what we actually can do with it. So for this first demo, I have a very small class here called MyBuggyApp, and there's just a couple of lines of code. And this is valid Java code, right? There's no red squiggly lines in the IDE. And if I am going to open up my console and run maven clean verify, it will compile fine. But there's still something wrong with this code. Somebody spot anything that they say, okay, well, that just doesn't seem right? Just raise your hand, shout it out. Yeah, go ahead. Sorry? Unused methods, yeah, that's one thing, and not quite the one I was going for now. That's for the next demo, but yeah. The exception, indeed. So we create an exception, but it's not thrown. And usually that's not the way you want to handle exceptions, and you want to work with exceptions, right? So even though this is valid Java code, it is most likely not actually what we meant, and we wanted to throw the exception here. Now let's go to our pom.xml file and go to the configuration of the Maven compiler. And I'm going to insert a snippet here that adds error-prone as a compiler plugin. So for that, we need to set up the annotation processor path of the Java compiler. That's where it looks for plugins. And we use the -x plugin with the name error-prone, which forces the compiler to load this plugin from the annotation processor path. And by doing this, and also setting the compile policies to simple, which is for now necessary because there's a JDK issue open that would fix this issue. But for now, we need to configure this for error-prone to work correctly. Now, if we run the compilation again, you will see that something different happens. Rather than having a successful build, we actually get a Java compiler error. Because again, error-prone is a compiler plugin, so it can emit compiler errors on things that it thinks are wrong. And here you see, okay, there's a dead exception, right? So it's created, but not thrown. And you can also go to the bug pattern page if you want to, get more explanation on the background of the issue. But the interesting thing here is that it doesn't just say, okay, there's something wrong. It also offers you a context-specific suggestion. Right? It says, did you actually mean to write throw new illegal argument exception? And we go back, yeah, well, that's actually what we wanted to have here. And then maybe a little light bulb might go off in your head and say, well, if this tool actually can produce this kind of suggestion, could it also apply this for me? And there the answer is also yes. So if we run error-prone not in checking mode, but in so-called patching mode, and we can do this by configuring the plugin a bit more with the EP patch checks flag, where we say, okay, we enable these checks, and for now, for the demo, I just enable this single check for patching. Then we can also configure a patch location, so it can emit a patch file, giving the change. But for now, for the demo, it's nicer to do it in place. So we'll just update the code in place once it sees a bug check that it can correct for us. So if we now run the build again, it is now not yelling at us anymore, but it's actually doing useful work. And going back, you can see there's now throw new legal argument exception. That's pretty cool, right? If you have a compiler plugin that can do that for you. And it's not just doing this for the dead exception check, but there's many, many more checks in error-prone where this applies and where this can be done for you. So it's a little bit like autocorrect for your code, only a bit more useful than on your phone, I would say. So like I said, error-prone is not just about doing checks. It can also rewrite. But the checks that are in there, so the ones that come out of the box, also aren't just about core Java. So the example that we just saw is really a core Java pattern, right? Where we have this checking for unthrown exceptions. That's fine. But there's also some specific ones, for example, for Android, because, well, it's a Google project. So, of course, they want to do some specific checks for Android. But there's also checks in there for API usage and then wrong usage of JUnit. There's even something in there for Joe.time, which by now we hopefully don't use anymore. But it goes to show that there's more there than just core Java patterns in error-prone. A lot of these checks are on by default. If you are actually going forward and start using error-prone, you might be a bit more deliberate about what you enable and what not, right? Because, for example, we disable Android checks because we don't want to waste CPU cycles because we're checking backend services. There's no Android code in there. And you might also disagree maybe with some of the assessments of these checks, right? So some things that error-prone thinks are errors, you might say, okay, maybe it's just a warning. And then you can override it using the XEP flag and give the check name. Then after the colon, also configure the severity that you want to attach to it. Or you can turn it off if you say off after the colon, as you can see with the Android injection before super flag here. Now, if you start enabling error-prone on your codebase, you might get a lot of errors and warnings, of course. And you could, of course, rewrite them and then get them in order, etc. But there might also be some places in your code where you're not quite ready to do that yet. Or where you say, okay, I'm actually deliberately writing this code here. So I may want to have this check for other code, but here I do want to make an exception. And you can make that exception using the @suppress warnings annotation, which is the default annotation that we also use to suppress actual real Java compiler errors and warnings, right? So that is the very same mechanism that is used also by error-prone. As it's a compiler plugin, it's so close to the Java compiler infrastructure that it can just use the same approach. So that is something that you definitely want to tackle when you start introducing error-prone. So it will take a bit of tweaking, and it will require you to go over your code, of course, and see what fits and what doesn't fit in your team, in your code base. Now, there's one other usage of error-prone, and error-prone as a compiler plugin that's not quite about a bug pattern, but that's also very useful nevertheless. And this is also something that we use at Picnic, and that's using the var check. So you may all have this annoying coworker who says, okay, we need to go fully immutable, right? We need to have final everywhere, and it makes it easy to reason, etc., etc. And you know they're somewhat right, and there's something to that. But at the same time, you also maybe do not want to introduce final everywhere because it's also a bit noisy in your code, and then sometimes really what's the point, right? So with error-prone, you can also turn this a bit around and say, okay, if we're enabling this using error-prone, then we assume all local variables and all parameters are final, so not reassignable anymore. And if you do want to have a variable that can be mutated and that can be reassigned, then you must use this @var annotation, and then it's okay. Then we can allow it. So it's actually flipping the defaults. And I think for us, this really is really helpful. And we do occasionally have a few places in our code bases where we have this @var annotation, but it turns it a bit around, right? So if you want to have this reassignable variable, then you need to introduce a bit of noise and make it really clear this is deliberate. And if you don't, well, then we just assume that it's final. Which again, it's not really a bug check or bug pattern, but it's an improved way of working with some of the defaults that are in Java that you can do by using error-prone. Now you might be thinking, okay, there's a bit core Java checks in there. There's maybe some libraries in there that are covered, like JUnit, as we saw. But what about my specific libraries? Is there anything for that? And if you look around in the ecosystem, there's actually quite a few libraries that contain error-prone BugChecks that you can hook into your annotation processor path that will be picked up by error-prone, and that will specifically check for bug patterns and usage of the APIs, for example, of Mockito or of SLF4J. So there's quite a few community contributions, and this ecosystem is pretty interesting to look at. And it will hopefully fit the libraries that you are using when you look around. But that also might raise the question of, if they can publish these checks and if they can create it, could we also do this, right? Could we also do this for our team, for our company, with our particular usage and our opinions about usage of APIs? And the question there is, yes, you can also do this yourself if you want to. You don't have to, but you can. And at Picnic we do, and I will show some examples of that later. But the idea is that if you want to extend error-prone, and if you want to start customizing it, you can create your own BugChecker implementations. And I'm going to show another demo. And in this demo, we will have a second Maven project, so next to this buggy app that we just saw. And in this second project, called My BugChecker plugin, we are going to create a empty method checker class, which extends BugChecker from error-prone. And of course, we're going to implement some logic there to find empty methods in our classes, in our code base, which are then reported as errors, if you want, or as warnings, however we configure it. But the goal here is that we can hook into error-prone and create our own custom logic to actually find patterns in code and flag it, and even emit suggestions for that as well, so we can use it to also automatically rewrite, as we just saw. Now, once we have this empty method checker class, we need to put it into a jar file. We need to put that jar file on the annotation processor path of error-prone as it is applied to our other application, so to the buggy app. And under the hood, it actually uses the service loader mechanism of Java to instantiate this bug checker and to detect them and to find them. And to make that a bit easier, I'm going to use another project from Google called AutoService, so that we can just put an annotation on the class and make it service loadable, rather than using the old awkward way of introducing a meta-inf directory, which particular file and some things that we need to do there. We can just use an annotation for that from the Google AutoService project. So all in all, we are going to create a new jar file that we're going to put on the annotation processor path of our application, and it contains a custom bug check that we are defining, that we are creating here on the spot. All right, so let's go to this second project. I'm first going to show the POM file here. Again, we're going to create this My BugChecker plugin, a jar file. And in the compiler plugin here, we see that we're not defining error-prone as a plugin because, well, I don't want to go full inception here and then check the check. But I do add Google AutoService as a compiler plugin here to make this service loading a bit easier. And we'll see how that works in a bit. Of course, I also need to add some dependencies because I'm going to write against the error-prone API here to implement this bug check. So you will also need to add this, and I need to add the AutoService annotation here to be able to use it in the code as well. All right, enough about the setup. Let's have a look at the code. So it's still a fairly empty class here. And what I'm going to do is I'm first going to make sure that this class will be service loadable, and it will be service loadable under the BugChecker class type, because that's what error-prone is going to look for on the annotation processor path. And in order to actually make this into a usable bug pattern, I need to use the bug pattern annotation. And I can say, okay, the name is empty method. There we go. We also need to provide a summary that is shown once the error is triggered. So we don't do nothings. There we go. And we also need to attach a severity. And let's make this an error, because why not? So that is sort of the metadata that we need to provide and the setup. Now, of course, we also need some way to actually implement this pattern. And what error-prone offers here is a sort of implementation of the visitor pattern. So error-prone hooks into the abstract syntax tree of the Java compilation unit that is being compiled. And through this bug checker, it allows us to hook into when it detects fields, methods, and other things. So for this check, we're only interested in looking at methods. So I'm going to implement the method tree matcher so that we only have to override the match method implementation here. So this will be called for every method that is encountered during compilation. Now, in here, we need to write some logic, right? So I need to say if on this method tree that has been provided, in the body, looking at the statements, they're empty, then we want to do something, right? We want to flag this. So we're going to return, and I'm going to use this helper method called describe match. I'm going to say this method tree that we just matched, I actually want to emit a suggested fix for this. So I'm going to say suggested fix. And in this case, we're not going to replace or swap or whatever. I'm going to suggest to delete this node. So I'm going to suggest to delete this method tree. And that's actually basically it. And all the infrastructure around the compilation, compiler plugin, ErrorProne itself will take care of actually doing the work if we want to. So notice that we're not talking about line numbers, etc. here. We're really talking about abstract syntax tree concepts that are provided to us and that we can act upon with the suggested fix. And if there's nothing to do, then we return a no match here, and it will continue on its merry way. All right. So with this in place, we can, in this case, Maven clean install it, because we need to install this jar file into our local repository. And I'm going to copy the coordinates that we have here so that we can add it to our first project, right? And as you can see here, this do nothing method, and that's the one that we're trying to get rid of. So what I'm going to do, I'm going to add another path entry to our annotation processor path, add the coordinates of the newly created jar file here, and I also need to enable this check, right? Because remember, we were in patching mode, and I also need to tell it, also take this new anti-method bug check into account when patching. And if everything goes according to plan, we're going to call Maven clean verify, run the code, and poof, it's gone, right? So we implemented something that we thought was a bad thing to have in our code base. We provided this as a bug check to ErrorProne. It runs. It actually turns this suggested fix into a rewrite on our code base. It does this for us, and it's like magic, I would say, right? It's actually pretty cool. So with this in place, you can start thinking about applying these bug checks for things that you see happening in pull requests every time and time again, right? Where you have the same discussion over and over, and you want to actually automate this away. And that is what ErrorProne makes possible using these bug checks. Now, let me go back to the presentation to give you a little bit of a taste of what we use custom bug checks for at Picnic. There's actually a couple of categories here. So on the one hand, we have some bug checks that are addressing what we would see as correctness issues with usage of APIs. So again, it's all perfectly valid compilable Java code, but the way some of the APIs are used just don't fit into the pattern of how we think they should be used. For example, we don't want people to rely on the default time zones. So if there are any APIs that are using date and time manipulation where you can provide a time zone, you must, right? So and we don't want to fall back to defaults there. Also, we want to disallow, for example, the usage of local date time now and the system current time millis and these kind of things in favor of an approach where we inject a clock, or as of Java 17, an instance source, so that we can later actually inject a mock version of that to actually mock the time and make sure that we can write unit tests without relying on actual wall clock time. So these are all things that are institutional knowledge that you, together with your team, build up over time, and that you can try to enforce using discipline and discussions on PRs, etc., which is all good. But if you can automate it away, why not do it? Another category of errors is where people use APIs that will lead to runtime, maybe not errors, but maybe to issues. An example is this sleft4j usage, where people might pass in a log line using a placeholder that's actually the Java formatting placeholder, the %s, whereas sleft4j expects these curly braces as placeholder, right? This all compiles, this will run, it will even log something, but it will not log the thing that you expect it to log. So we wrote a check here that actually looks at the string and tries to see if there are any of these formatting things in there that shouldn't be there, and then give you a warning and a suggestion of replacing that. And on the right-hand side, similarly, you might have multiple placeholders and only provide one of the parameters. Again, this will not break at compile time. It will also not break at a runtime, but it will not do the thing that you expect it to do. So again, these are things that will prevent these errors from even occurring and from even being merged into our main line. And of course, there's also discussions of style. Right? And this is also something that you can use these bug checks, these error-prone bug checks for. So here's an example where a bug check actually looks at the annotation syntax and tries to sort of normalize this. So if you have this single-valued annotation, you can say value is something, but you can also omit the value is, which we think reads nicer, and we want to enforce across our code base. Similarly, for the annotations where you can have multiple values and you use this array syntax to actually provide only a single element, we say, okay, we'd rather have you just provide this myServiceable class directly without the array syntax and without the trailing comma, which is, by the way, valid Java syntax. It's just not something that we would like to see in our code base. So correctness and style, these sort of issues you can tackle using error-prone and these custom bug checks, or even some of the bug checks that are provided by the community for your libraries. So what's not to like? Well, as you may have seen, I've only shown the header of these bug checks, right? And that looks pretty, but there's also an implementation there. And we already saw that to implement a bug check, you need to know about a Java abstract syntax tree, the traversal, keep the state, and actually implement this check, which for our trivial example wasn't too bad. But even our trivial example matches too much, so we would have to refine it if we actually want to put this into production. So working with these bug checks and ASTs and traversal can be quite challenging. It may be worth it, but nevertheless, there's a learning curve there. Especially if you also want to emit good replacements, right? If you don't just want to flag something, but also want to rewrite it into something else. So that being said, you might ask yourself, isn't there something that we can do about this? And there's also another thing that you can do using error-prone, and that is to start using Refaster. With Refaster, you actually get a new option where you say, okay, maybe it would be better to express this bug pattern or this old pattern of usage in concrete Java syntax, and also express the new way of writing things in concrete Java syntax, and have error-prone and Refaster figure out how to match and how to rewrite so that we don't have to care about that. And that's also, I would say, quite magical if you make this combination. So I'm going to show a third and last demo for that, where we are going to create such a Refaster template. And the setup there is that we, again, have a new Maven project. In this case, it will contain a string isEmpty template class. And we're going to have multiple methods on there. And we annotate one or more of these methods using the add_before template annotation, which says, OK, if you see structurally this kind of code, that's where we want to match. And then in the after template annotation, we can write the code that we want it to be transformed into. So it's sort of a rewrite rule, or not sort of, it's actually a rewrite rule that we're expressing using concrete Java syntax. Now, what you then need to do is to run the Java compiler on this class using yet another compiler plugin called the Refaster resource compiler, which turns this template into something that can be executed, that can be applied by error-prone. And this will be put into an empty string.refaster file in this case. And that file we're going to provide to the buggy app that we just saw, that we are going to use to do the rewriting. So the actual class file of the string isEmpty template will be ignored. So that's actually not something that we're going to use. It is all about the side effect of creating this Refaster file that can then be used by error-prone to do the rewriting. Right, so let's go to our third project. Again, just to give you a little taste of the setup around it, we have the POM file, and in the Maven compiler plugin, we are configuring a different compiler plugin. So the Refaster rule compiler, as I said. And we're going to provide a output file, which is in this case the empty string.refaster file. And on the annotation processor path, we are putting the error-prone Refaster artifact in this case that contains this Refaster rule compiler plugin. We also need to add error-prone Refaster as a dependency because that's where the add_before template and the add_after templates, annotations, etc. live. So we also need that on our class path. Now, before we dive into the rewrite rule, the thing that we're targeting is this expression. So we have this args0.equals empty string. And as you might know, there's also a very nice .isEmpty method on string, right? Which would be much nicer to have here, rather than having .equals empty string and a bit more intention revealing. So if you want to enforce this using a Refaster rewrite rule, we can do that as follows. So we have this template class with 2 before templates. And here, the method name doesn't really matter. But what we're saying is that we want to match expressions of type string. It doesn't matter what the structure of this expression is, as long as it's a string, as long as it evaluates to a string. We want to match it, followed by an invocation to equals with the literal empty string. So that's our precondition. That's what we want to match. And then you can also see that we have a second template here, where we are, again, matching any string expression. And we say, OK, we also want to match invocations of the .length method, where you compare it to the literal 0. So this is also something that we would like to rewrite to isEmpty. So I'm going to add the after template implementation here, which is pretty straightforward, actually, where we say, OK, again, we take this arbitrary string expression, which would be the same as the expression that is matched here, and then we rewrite it to this expression, and then .isEmpty. And by the way, we also want to do this for any negated expressions, right? So also if it says not, then we also want to apply this the same transformation. So now what we need to do is we need to not release, but let's run Maven clean verify on this. And a side of that effect of that should be that we have in our one directory up the empty string.refaster file. And indeed, that was emitted. And now we are going back to our first project, right, which contains the code that we want to rewrite. There we go. And I'm going to go into the POM file. And rather than doing the check with the built-in checks or the custom bug check that I just defined, I'm going to configure it differently. And the patch checks now point to a Refaster file, in this case, which we just emitted. And again, I'm going to run Maven clean verify, which means that we're going to run error prone on the code in patching mode, with in-place patching in this case. And I go back, and poof, it says .isEmpty. And it would have worked regardless of what kind of expression we would have had here, right? So again, this is pretty flexible in terms of what it matches. So what do we use this for at Picnic? Well, one of the applications here is when you, for example, move from one version of a library to another. And an extreme variation of that is moving from one version of Java to another version of Java. So when we migrated, for example, to Java 11, there's lots of new goodies in the APIs, right? And you could say, OK, well, from that point on, we just start using it, and we sort of do the Boy Scout rule. If you see something, you fix it, which sort of works, but not all code is touched. And then you get this sort of halfway situation where some of the old APIs are there and some of the new APIs are used, and people are confused. What should I do? So why not write some Refaster rules to actually make this migration easier, and not just run on Java 11, but also make the most out of the new APIs that are there. And one example is the optional API, where first we only had isEmpty on optional, and then in Java 11 we got isPresent. So with this simple Refaster rule, you can easily write all of the not optional isPresent invocations in your codebase to optional isEmpty. It seems small, but it's super easy to do, and you can actually run it over all your repositories, and we have the tooling in place to actually do this, and we have a platform team that makes this happen across Picnic. So in that way, you can very easily migrate and have a clean slate and actually start using the APIs the way you want them to. So just to give another example of such a JDK-based kind of thing, and here you can see that I'm using refaster.any-off to do multiple matches, which is kind of similar to having multiple add before templates. But here we are rewriting the idiom of filtering on a stream of optionals and then checking with optional isPresent if there's something in there, and then mapping optional get over it to get the actual values of the non-empty optionals to stream.flatmap optional : stream, which also was introduced in Java 11. And the interesting thing here is that the top option in the Refaster any-off is the JDK approach that we had, but we also use Guava as a library, and it already had some sort of similar functionality in there with stream.flatmap and then streams : stream, and streams comes from Guava. But we'd rather use just JDK functionality in this case, because it's now there, so we can also rewrite that. So it also shows the Refaster rules are not just about core Java libraries and rewriting there, but also apply to any kind of library where you would want to have some patterns that you match and that you rewrite into another API usage. And similarly, we use this also for spotting some anti-patterns in, for example, the use of Project Reactor. We do have quite a few projects that also use reactive programming. Won't go into all the details here, but what you can see is that it's pretty straightforward to match any kind of API usage and rewrite it to something that you think is best as a team. And in this case, the add use import policy here is there to also make sure that the toOptional method that is used here is actually added as a static import to the file, so that it will keep compiling and will be valid Java code. So using Refaster is not a complete alternative to the BugChecks, but in a lot of situations, and the ones that I've shown, it is an easier way to get started, to migrate from one sort of fluent API invocation chain to another API invocation chain. There's also the possibility to match blocks of statements and rewrite it to other blocks of statements. That sounds on paper pretty useful, but in practice, having exact sort of statements matching in multiple statements, consecutive statements matching, is a bit more rare. So for us, it's mostly about this expression matching and having these fluent pipelines that you rewrite from one usage to another. So comparing these a bit, I would say Refaster, it's super easy to work with because you can use concrete Java syntax, but there's somewhat of a limited expressiveness in there, and there's limits to what you can do using Refaster rules. Whereas BugChecks, on the other hand, give you full access to the AST. You can go nuts, but it's also a bit complicated, and there's a steep learning curve there. So definitely pays off to really think about which of the two you actually need for the particular challenge that you want to tackle. So and Refaster rules are also only about rewriting, right? So from before to after, whereas BugChecks can also be about just flagging some pattern and just detecting something and then making sure that people are aware of this and fix it themselves in some other way. So you might also wonder, okay, that's very cool. We saw this working locally, but how do you actually apply this in your CI, in your development flow? So we encourage developers to also run this tooling locally and to make sure that everything is okay. But on the off chance that something gets committed and then pushed to a PR where not all the rules are obeyed and not all of the rewrites have been applied, then this also runs as part of our CI build. And it's actually pretty straightforward. So we have this PR, there's a certain commit, right? And if we run error prone in patching mode on this particular commit, and there's a non-empty diff after doing so, that means that something has changed and that thereby not all of the rewrite rules and not all of the checks have been actually applied. So Danger, which is another nice integration tool to work with GitHub and some of our CI tools, will post a message to the PR saying, okay, please check and run this patch file that you can run locally to fix this. And that way, PR cannot be merged unless all of the rewrite rules have been applied and all of the bug checks have been satisfied. So that's the way we make sure that every single line of code that is committed to master actually adheres to what we think are good rules and what are good bug checks within Picnic. So there's more to tell here, but it's now time to go try out this yourself. As I said, it is a pretty low barrier to entry, right? You would just have to configure a compiler plugin to start using it out of the box. So go to the error-prone site. I do have to give a fair warning that within Picnic we are running a fork of error-prone. We have upstreamed some of our changes already to Google. Not all of them have been accepted yet. A lot of them are around the ease of use of using multiple Refaster rules and combining them, etc., which apparently for Google is not a big deal because they have probably some other tooling internally to do this. But for us it is. So if you also encounter this, if you also are going to use Refaster at scale, I would highly recommend also checking out our fork and maybe start using that one. I also want to highlight that one of my colleagues, Stefan Schroeves, is really the brain behind this at Picnic. So if you have any in-depth questions or want to just chat about the intricate details of error-prone, reach out to him. He'd be happy to have that chat with you. And with that, we're already at 40 minutes. thank you so much for being here, and thank you for your time. I hope you enjoyed what you saw. And again, if you liked it, feel free to come up and have a chat. I'd be happy to answer any questions. We also have a booth here, and we have some developers walking around, which you can talk to as well. We'd love to chat with you. We'd love to even work with you, maybe as part of our platform team, improving this tooling. So that being said, thanks for being here. I hope you are going to try this out yourself.